Now that you're familiar with the y86 architecture, we're going to start learning about some instructions. And we're going to start with some of the simplest instructions, which are the move instructions. You can move things to and from registers, to and from memory. We'll walk through the different instructions that allow you to do that. Let's begin with the instructions that move the contents of one register to the contents of another register. We're going to use a notation that precisely describes the semantics of instructions. So the way we're going to do that is you can imagine thinking of the register file as an array that is indexed by the name of a register. So in this notation, the name of the register, i.e. the number, is RA. So RA happens to be 0. So this says take the 0th register in the register file and take its contents and move that to be the contents in the register file of the register RB. So in all our instructions, we may have an RA and RB, or we may have both of them. In this register to register move, we have both an RA and an RB, and we're going to use those as sort of indexes into the register file. So the instruction that moves data between two registers is called register to register move queue, or RR move queue. Its opcode is a 2. For now, we're always going to have 0 for the function, but you'll actually see later that we have some flexibility there. So stay tuned for that. And then we're going to specify two registers. So in this example, I'm specifying register 8 and register 9. So register 8 would be RA, register 9 would be RB, and this would produce the memory representation where one byte contains 2 0, and the next byte contains 8 9. So this is opcode function RA RB. And what that says is take the contents of R8 and put it and make it be the contents of R9. So register to register moves are quite common. We use them all the time to move values around. Our next instruction is going to let us initialize a register with a constant value. This is called IR move Q for move immediate to register move Q. The Q stands for quad word. Using our same notation, there is some val, which will be expressed as an 8-byte constant in the instruction. And we're going to take that value and we're going to place it in the register file into the register whose number is RB. So in this case, we don't need RA. And for instructions that don't need a register, we always place an F in that location. So this indicates the byte that should contain RA and RB. The RA one will always be F because we don't need RA. And then the other half of that byte will be RB. So let's imagine that we want to move the value cafe into R9. Our opcode is 3. There's no function code. So we get 0x3 for the first byte. I'm sorry, 0x30 for the first byte. And then the next byte is RA RB. So 0xF9. And then in these 8 bytes, we need the constant value cafe. Now remember, in memory, things are laid out in little endian order. So if we look at the value cafe, the low order byte is FE. So that is the byte that comes first. The next most low ordered byte is CA, that comes next. We're not showing the rest of the bytes, but they are in fact zeros. Right? So in decimal, the number 10 is the same as 0010. So in here, cafe is the same as 0000 and all these zeros, cafe. So this is in memory, what it looks like. And this is how you would write the instruction. So that's how we just initialize a register with a constant value. The next thing we might want to do is to move data that is in memory into a register. Processors usually have one or more addressing modes that give you different ways to access memory so that you can move values from memory into a register. The y86 has only a single addressing mode, so that makes your life easier. There's only one way to specify data in memory and then move it into a register. So the addressing mode says, take the contents of RB. So in the instruction where you see RB, that's a register number. Go to the register file, get that value. To that value, you're going to add the value in the 8 bytes in the instruction. So we take the contents of the register, we add the value from the instruction, and that is going to give us an address in memory. We can think of memory as a big array of 8-byte quantities, quad words. And so we're going to take the data that is located at that address, and we're going to put it into the register indicated by the RA field in the instruction. So here's the encoding of our instruction. We have an opcode of 5 with no function code, and we have 2 registers, RA and RB, and then we have this 8-byte constant. So if we want to move from memory into a register, we use the MR, memory to register move queue instruction. And now we specify the memory address by some constant added to the contents of a register. So in this case, I've said, take the register RSP, whatever its value is, add 4 to it, and then use that as an address and move the value that's at that address into R9. So in this case, if in fact we said that RSP happened to contain the address 4000, then this would say, go to address 4004 and load that value. Use that as an address, take the value at that address, and put it into this register R9. So when we encode the specific instruction, we encode the opcode, we encode RA, which is R9, RB, which is RSP, which is 4, and now we want to express this constant as an 8-byte constant. 4 is the low order byte, so it comes first, and all the other bytes are zeros. So that's how we move a value from memory into a register. And I bet by now you can figure out how to move from a register into memory. It's almost exactly the same with the arguments swapped. So instead of a memory to register operation, we're doing a register to memory operation. So this has a different opcode. Its opcode is 4. And semantically, what we're doing is we're saying, whatever is in the RA field of the instruction, go to the register file, get the value of that register, and then we're going to put it into memory. And the place in memory we're going to put it is the address that you get by adding the constant in the instruction to the contents of the register specified in RB. So the encoding looks quite similar to the previous instruction. We have an opcode of 4 instead of 5, function of 0, and then we have 2 registers, RA and RB. RB is the one we use to compute the memory address. RA is the one that's going to tell us, in this case, which register has the value that we want to read. And then the constant is going to tell us what we're going to add to the contents of RB. So let's say that we take whatever's in R9 and we want to put it at the address represented by 4 off of RSP. So we encode the 4 and the 0 for the opcode. We encode our registers. RA is 9, RB is 4, which is RSP, and our constant is once again 4. So those are your 4 move instructions: register to register, a constant or immediate value into register, the IR instructions, and then what are called load and store instructions on many machines are sort of named more specifically. So usually a load instruction reads something from memory into a register. We call that load instruction MR move queue, for memory to register move queue. A store instruction usually puts data into memory, and here we call that a register to memory move queue, or RM move queue. Once you start writing programs, this will all make perfect sense.